Imagine a monster so massive its very own skeleton would instantly shatter like glass just by taking a single step. We all know and love the towering, city-crushing titans of the silver screen. But what happens when you drag these cinematic giants out of Hollywood and drop them into the harsh, unforgiving light of real-world physics? The results are surprisingly messy and deeply fascinating. Let us start with the undeniable king of the monsters, Godzilla. Bursting onto the scene just a decade after the devastating atomic bombings in Japan, Godzilla was not just a random reptilian nightmare. He was an awe-inspiring, radioactive embodiment of absolute terror. He represented a very real cultural fear of nuclear devastation brought to life through legendary storytelling. But soon, this radioactive titan was not alone. The cinematic universe rapidly expanded to include an entire bizarre ecosystem of colossal creatures. Take a look at Gamera, a gigantic flying turtle equipped with jet propulsion legs. Created as a response to escalating environmental degradation and pollution, Gamera literally eats fire and was once blasted into space, heading straight for Mars. Then you have Rodan, a massive supersonic pterodactyl whose very flight can effortlessly tumble heavy trucks in its destructive wake. And we cannot forget Mothra, the stunning, divine protector of nature who amazingly transitions from a colossal caterpillar into a breathtaking giant moth. It is absolutely spectacular to witness. Every gigantic footprint leaves behind a mesmerizing trail of epic cinematic destruction that captivates audiences worldwide. These gigantic creatures are incredibly fun to watch as they spectacularly wrestle and demolish entire cities. However, a massive biological problem immediately ruins the fun when we apply real science. It is an unbreakable rule of physics known as the square-cube law. Let us completely simplify this complex scientific term. Imagine you have a tiny, perfect wooden block. If you magically double its height, it doesn't just become twice as heavy, it actually becomes a staggering 8 times heavier. Why? Because you're increasing its total volume, its length, width, and height. But here's the critical catch. The cross-section of its structural supports, like its legs or bones, only becomes 4 times stronger. Now apply this exact same math to our towering, scaly friend, Godzilla. If you scale a standard dinosaur up to a monumental 400 feet tall, its weight skyrockets to 1 billion tons. However, its leg bones don't magically wide enough to support that spectacular new weight. In reality, the very second our giant reptilian king tries to proudly stand up and roar, his massive leg bones would violently splinter and crush under his own unimaginable bulk. He would immediately collapse into a tragic, immobile blob of protoplasmic stuff upon the earth. This exact same unbreakable physical law is precisely why you never have to worry about a terrifying city-sized ant crawling over your house. Sure, a tiny little ant can astonishingly lift 50 times its own body weight, but if you magically enlarge that exact same ant to the staggering size of a school bus, its heavy outer shell, called an exoskeleton, would become overwhelmingly thick and dense. The giant insect would instantly suffocate and desperately collapse under the sheer crushing weight of its own armored body. Physics simply forbids it. So, while it's incredibly thrilling to imagine a massive radioactive lizard battling a giant supersonic turtle right in the middle of a brightly lit metropolis, the mathematical reality of our universe keeps us perfectly safe. Gravity, biology, and the incredible square-cube law remain the ultimate undefeated champions of the world. The next time you grab your popcorn and watch a colossal titan fiercely blast atomic fire into a dark, smoky sky, you can happily smile knowing the truth. These beautifully designed monsters are magnificent feats of human imagination, deeply rooted in our historical fears and environmental hopes, but thankfully, they're strictly confined to the magical realm of cinema. Physics will forever keep these awe-inspiring behemoths safely locked away on the movie screen.